So I got an email from one of y'all, and I should have done a better job of finding out what group you're in. So I don't know if she's in this group or if she's in group A or group C. And she didn't say this part, so I exaggerated. I put, Chavez, I enjoyed finding vertex and quadratics by completing the square. She did not say that. I added that. I want to pretend. Well, I'm not pretending. I hope you guys are enjoying some of these. But she did say, what if I have a quadratic? She didn't say it in this way, but she said, what if I do not have a equals 1? Like, what if it doesn't start off like that? And then she gave me some general equation, and I replied back, and I solved her problem. And it was something similar to this one. I don't remember if I stole this one from hers or if I got this one from my notes, or I might have just made this one up completely entirely. I don't remember because I typed these notes out like at 2 a.m. or something. So here we go. So state the coordinates of the vertex of the parabola 4x squared minus 16x plus 13 without a calculator. Without a calculator. Because obviously with a calculator you can do anything, right? All right. So without a calculator, guys, here's the whole point. We want to get to something that looks like this. So I'm going to rewrite my equation. 4x squared minus 16x plus 13. So I make some observations and I recognize, well, there's nothing in front of that x there. So obviously, this x squared, I'm going to have to factor something out, right? So I'm going to group these two terms, the ones that have x's, and I'm just going to factor out whatever's in front of the x squared. If for some reason our b right now comes out that it comes out perfect, every single I made all these questions where everything comes out beautiful, but sometimes some of the numbers get kind of mushy or kind of ugly, and we'll see those questions when we get there, but right now we're not there yet. We'll wait for all of us to be back on campus, or maybe some of us will be back, so we'll wait to do the tougher ones once we're all back at full throttle. So here we go. I take the first two terms and I'm going to factor out a 4. When you factor out a 4, I'm going to have x squared minus 4x, and I'm going to leave some space, and I'm going to close it, and I'm going to put plus 13. That 13 is that guy. I have not changed anything. If I distribute the 4, I get back the 4x squared minus 16x. Okay, so now with these two terms that I have in here, I'm going to put a plus. Now I'm going to go ahead and complete the square with that. 4 divided by 2 is 2, and 2 squared is 4. So I'll put a plus 4 here. So this is your magic number, quote unquote. Now, I'm not going to put a minus 4 here, because what you really did, notice you have a 4 on the outside. What you really did was make this heavier by 16. So I'm going to subtract 16 for balance from the 4 times space minus space plus 4, from the 4 times 4. All right, I'm trying to write good notes here, I don't know, hopefully these are supposed to be blanks, but I could see how people can confuse them for minuses. All right, here we go. Or I guess I can just, it doesn't matter. All right, so now the trinomial here, it's going to be 4 parentheses x minus 2, close it squared. We've been doing that the last 2 days. And then the difference between 13 and 16 is just 3. The 16 is larger, so minus 3. So to answer the question, what's the vertex? The vertex is 2, negative 3. Now, some of you are saying, okay, Chavez, I get it, we just did it. But why? I don't understand why it works. Well, it works because, one, you're not changing the function. So check it out. What I mean by that is, I'm going to go ahead and expand this. Whatever you see in blue, don't write, guys. Just observe this. Just observe all this right here that we're just doing right now. So don't write this down. Just listen. So if I were to expand this out, so let's see, 4 parentheses. I'm going to go ahead and FOIL that or expand it out. X times x is x squared. And then x times negative 2 is negative 2x, but you're going to have 2 of those, so minus 4x. And then negative 2 times negative 2 is a positive 4. And then bring that minus 3. Oh, what did I just do? Minus 3. So now let's go ahead and distribute. So when I do that, I'm going to write it up here, guys. I have 4x squared minus 16x plus 16 minus 3. OMG, look what happens right here. 16 minus 3, so 4x squared minus 16x plus 13. That is the same, guys. 4x squared minus 16x plus 13. It's the same. So now you can see why it works. You're not changing anything. You're just rewriting it so it can be in vertex form so you can, quote unquote, see what the vertex is. And yeah, it really is that simple, guys. All right, let's go to the next one. It says that yesterday I made a set. You didn't do any parabolas that were downward. That means where the A is negative. What A am I talking about? This is how you say in math negative, guys. So that means A is negative. So when you see math textbooks that say A is less than 0, it's telling you that the expression that A is always negative. So here we go, guys. We're going to practice again. I have a negative expression on the front. So this time I made sure to put that in there. So I'm going to rewrite. Well, I guess first let me write what I want. And again, you don't always have to write what you want, guys. You can go ahead and if you already feel like you're a beast, you don't even have to write this right here. All right, now I'm going to rewrite that negative 2x squared plus 12x minus 21. I'm going to group these x's here, these two terms. Never go back with an x, guys. That's just asking for it. Leave it in the past. So there we go. When I factor out that negative 2, you're going to have x squared minus 6x. I'm going to leave some space and minus 21. That 21 is that guy. I don't see any mistakes. I think we're still good. I take this middle number and I divide it by 2. 6 divided by 2 is 3. And then I square it. 3 squared is 9. So I put plus 9. So now I'm going to balance it out. Negative 2 times 9 is negative 18. So I have to add 18 on the outside. So what do I have now? Negative 2x minus 3. Close it. Put a square on it. The difference between 21 and 18, what's that? 18, 9, 20, 21 is 3. The 21 is larger, so negative 3. And there it is, guys. Oh, I guess I haven't answered the question yet, right? What's the vertex? The vertex is 3 comma negative 3. All right. I hope we're feeling okay. I hope we're feeling good. Don't worry. We're going to do another example. So here we go, guys. Another example right here. So it says, find the vertex of the quadratic function. And I have this lovely expression here. And again, I'm going to write, because we're rookies at the moment, I'm going to write what I want. I want it to look like this. I notice there's nothing in front of that x there. So I'm going to write my expression, negative 7x squared plus 42x minus 3. I'm going to group these x's. They're in the past, remember? I'll stop joking, guys. So I factored out that negative 7 there. So I'm going to have x squared minus negative 7 goes into 42 6 times. So 6x, and it's a minus because negative times the negative is a positive, right? I leave some room. I put that minus 3 there. I'm getting ready to balance out. So I'm going to write, let's see, 6 divided by 2 is 3. 3 squared is 9. So I put a 9 right here. You just made this heavier by negative 63. So I'm going to have to add 63. Because 7 times 9 is 63, correct? So now I'm ready, guys. So now, let's see, negative 7, open parenthesis, x minus 3, close that dude up, put a square. And then the difference between 63 and 3 is 60. The 63 is obviously way larger than 3, so it's going to be plus 60. And there it is. And then to answer the question, the vertex is at 3 comma 60. If they were to ask me what's the maximum or minimum, this does not have a minimum because it goes down forever. It has a maximum at x equals 3. The y value is 60, or the maximum value is 60. And there it is. Pretty straightforward, guys. All right, so here we go. So this is today's lesson. A lot of you guys already know this. Now, for the last few years, I've been seeing more and more of you guys do, like when it comes to factoring, like, oh, let's factor this. I've been seeing a lot of you guys do this x there. And I don't blame you guys. It's fine. You can do that x all you want. But as soon as I make a, at the moment a is 1, as soon as I make a anything besides 1, that whole x deal breaks apart. And some of you, a very small percentage of you, can still do it with the x, but you have to figure out like alternate methods, like on the side, you do some rules, which is fine. If you want to continue going that route, you can, guys. I've been in teacher workshops where other teachers are in there and they literally they call it like the X game, and they do that over and over again. And I just laugh, like, okay. I'm not laughing at you guys. These are teachers, you know, they're supposed to be like masters of their craft. But you know, I mean, I guess whatever floats their boat, as long as they get all this stuff, as long as they pass this information to their kids, I guess that's all that matters. All right, here we go. We're pretty much doing the same thing as that X deal, but the only difference is we're just verbalizing it. So here's how I do it. And I think I prefer that you start getting like this so you can become faster. There's only one way to get X squared, X and X, that's it. And then there's two ways to get 20. So you can either go 5 times 4, or you can go 10 times 2. And I guess you can also say 20 times 1. I notice this is a positive, so that means my product have to have the same sign. Either they're both going to be positive or they're both going to be negative. I notice that this is a negative 12, so that means they both have to be negative, minus, minus. The 5 and 4 will not work because when I add those two up, that's 9. The 20 and 1 won't work because that's 21. But the 10 and 2 do work because when I add 10 and 2, that's 12. So 10, 2. And there it is. So the way we do that, of course, this is like we literally just talked about everything there when we analyzed it. So to make life simple, all you do is say two numbers that multiply to give you 20, that add up to negative 12. 10 and 2, you're done. And then keep the signs the same. And that's it, guys. And it really is that simple. So let's look at this one here. Two numbers that multiply to give you negative 2. Oh, notice it's a negative, so you're going to have different signs, one positive, one negative, and then they have to add up to an X. Okay, so here we go. X plus, X minus, and the only numbers that multiply to give you 2 is 2 and 1, and I make the 2 positive because I have to add up to a positive 1. So when I FOIL this out, it adds up to a positive 1. I hope that helps. That's not a nice happy face at all. All right, there we go. That's better. All right. No, the eyebrows kill it. You know what? Forget it. This is why I got a D in art. All right, let's continue. Example 6. Solve for all values of x by factoring x squared minus 10x plus 9 equals 0. All right, by now we're probably professionals, guys. So x, and then let's see, two numbers that multiply to give you 9, but add up to 10, and they're going to keep the same sign. So they're both going to be negative. It can't be 3 and 3, so it has to be 9 and 1. Minus 9, minus 1, it works. I'm going to equal that to 0 because it says equals 0. And it wants me to solve. Okay, well, since it wants me to solve, there's only one way to make this expression equal to 0. Well, two ways, I guess. If x equals 9, 9 minus 9 is 0. 0 times anything is 0. Or x equals 1. 1 minus 1 is 0, and anything times 0 is 0. So these two work, and you are done. See? Easy, guys. All right. Example 7. Solve for all values of x by factoring. So here it is. I'm going to move the 2x to the left-hand side. When I do that, I notice that they're going to cancel out. And then I'm going to move the 5 to the left. And when I do that, I notice x squared minus 9. And I know what you guys are thinking. Some of you guys are saying, why can't you just move the 4 to the right since the two x's cancel out? You're right, you can. But this problem specifically told me to solve by factoring. Now I hope that you guys recognize that this is a difference of squares. If you have no idea what I'm talking about when I say difference of squares, let me go ahead and write it out here for you guys. That minus sign is the difference. That's a square, and this is a square. So that's what difference of squares is. And that expression turns to a plus b, a minus b. Okay, so now that we know that, we come back here and like, oh, okay, that's x times x, that's 3 times 3. So I can rewrite this as x minus 3, x plus 3, see? Equal that to 0, and then you just go back to logic. The only way this expression will be 0 is if x equals 3, because 3 minus 3 is 0, and 0 times anything is 0. And the only way that I'm going to get another 0 is if x equals negative 3, because negative 3 plus 3 is 0, and 0 times anything is 0. And there it is, guys. Those two work. All right, let's keep going. Solve the equation by factoring 30x plus 27x squared minus 3x cubed. And maybe you're saying, Chavez, I thought you told me we're just going to be doing quadratics. Relax. Notice that all three terms have an x in them. If I factor out an x, I'm going to have a leftover expression that's quadratic. Now, the whole thing is not quadratic. The whole equation is a cubic. But I'm going to have an expression that is a quadratic. So let's go ahead and factor out an x. And let's factor out a negative 3 while we're at it, because I noticed the 27 and the 30 3 goes into all of them. So I'm going to put negative 3x because I want the highest degree to be a positive, parenthesis, and I'm going to write this one first because I like to write my degrees, the highest degree on the left, and then everything else as I proceed to the right, I want to be smaller degree. So I'm going to write x squared, and then negative 3x goes into 27 9 times, so I'm going to write minus 9x, and I'm changing the polarities, right, because I factored out a negative. And then negative 3 goes into 30 10 times, so it's going to be a minus 10. Close it, put equals 0. All right, then I'm left with this expression, and I believe we covered that one earlier. I think it's the same one maybe. And then two numbers that multiply give you 10, but add up to a negative 9. Notice that's negative, so the signs are going to be opposite. X minus 10, close, open, x plus 1, close, equals 0. Negative 10 times positive 1 is negative 10. Negative 10 plus 1 is a negative 9. All right, so now what we're doing is we're just solving for x here. That equals 0. Well, if negative 3 times 0, negative 3 times 0 is 0, and 0 times anything is 0, so that's one answer. And then if I make x equals 10, that would be another answer because 10 minus 10 is 0, and 0 times anything is 0. And then another answer is negative 1. Negative 1 plus 1 is 0. 0 times anything is 0. So here we go, guys. We have 3 answers. And by the way, a cubic function always has 3 solutions. It's just that sometimes they're imaginary. Just so a quadratic will always have 2 solutions, but sometimes the solutions are imaginary. And that rule applies if you keep going higher and higher in degree. Okay, let's keep going. So this one's from an ACT Science Math workbook. I am not making this up. This is the name, that's the title of the textbook I have. Whenever we get back in section, I will show you this book. It literally just says ACT Science Math workbook. So for those of you saying I didn't write my resource or my reference correctly, that's the title of the book. It's just ACT Science / Math workbook. All right, so I should have probably written the number, right, or the page. So my bad, I didn't put the page number. It says, which of the following represents an equation for which the sum of its roots, and I guess I didn't mention roots, but I'll talk about that right now, and the product of its roots is negative 4. Okay, so remember how I told you about solutions? So this is what it means. The root, y equals, and I'm going to write it like this, x minus h close it squared plus k. The root is where the y value is 0. So essentially, it's like what we just did. It's like this. Well, that's a cubic, but it's like this. See, negative 3 and positive 3 are roots. So if I were to graph x squared minus 9, it would look like this. Here's 9, negative 3, 3. So roots. So it's the same concept coming back down here. So now that we know that, so here's the difference between someone that scores an average SAT score or ACT score, because it is from an ACT book, and a very high ACT score. It's not that they know more math if they score a perfect math score. It's just that they're faster. And so a lot of you would probably say, oh, okay, a root of negative 3 and the product. All right, so x equals, x equals. So some of you guys, if an average student, I think would probably factor every single one out until they got roots that when they found the product was negative 4 and some to negative 3. But someone that scores really high is probably doing it like this. Of course, much faster because right now we're just explaining, right? All right, the product is 4. There's only one way to get 4, or I guess 2 ways. 2 times 2 and 1 times 4. So that's a comma there. So these are x1 and x2. Now, it says negative 4 and it says negative 3 here. So if the product's negative 4, that means one is positive, one's negative. So I haven't decided yet on this one. So on the 1 and 4, we're going to leave it blank for now. And the sum is negative 3. That's the sum. Well, it can't be 2 and negative 2 because if I add those two numbers up, that's 0. But 1 and 4, if I make one of them negative, I will get 3. Now, what do I want? I want it to be negative 3. So that means the 4 is negative. So that means that one of my x's has to be 1, and the other x has to be a negative 4. Because notice, if I sum those two numbers, you get negative 3. So what's my polynomial function? My polynomial function has to be x plus 1. Oops, no, not plus 1. The opposite of that, guys. X minus 1, x plus 4. Put the equal 0. In case you're wondering, why do they have to be opposite? Because these are the roots. That's what you want. So when you solve for this, x plus 4, the only way to get a 0 is if x is negative 4, which is this one. And the only way to get x minus 1 to be 0 is if x is 1, which is the one on the top here. All right, all you got to do now is just FOIL this. So let's see, x times x is x squared. Let's see, x times 4 is 4x, and then negative 1 times x is negative x, so it's going to be a plus 3x. And then negative 1 times a positive 4 is a negative 4 equals 0. And then all you do now is just match it. So let's see, which one is it? X squared plus 3x minus 4. Here we go. Letter B. Okay, so I don't think SAT and ACT scores tell you anything about intelligence, guys. It just tells you how good you are at testing to those particular exams. And that's it, guys. That's all we got today. So pretty quick. All right, so let's all start coming back, guys.